Oh, hi. Oh, you? I thought you'd already know the answer to this one. All right, let's get going. So the first reason we do it, and this is a quick one, is because it sounds cool. I mean, come on, 0 Day sounds like the title of a James Bond movie, and it definitely sounds cool to say you're working 0 Day. Now, the more simple, real reason is that we actually track vulnerabilities by the amount of days they've been public, and there is a really good reason for this. So, vulnerabilities arrive in software when we're writing software. Like myself, I write a lot of software every day, and likely I'm writing some number of vulnerabilities every day. You know, I hope not, I try my best not to, but I likely am, and that's true for most other developers, if not all. So, we write vulnerabilities because we're imperfect. We can't always consider every possibility that a system can go through, and that can lead to security flaws as well as just bad programming can too. But these vulnerabilities then exist once they're created and the software is given to, the people intended to use the software. But nobody knows about them, including the person that created the vulnerability. So at this point, it technically is a 0 Day, but it doesn't really get teeth until an adversary or some other entity gets their hands on it. And when it's really considered a 0 Day is when there's someone out there that knows about it and has some level of not great intentions. Their intention is not purely to fix it. And what can happen is if they are an adversary, right? Someone that is looking to hurt you, they have the ability to then launch that attack without anybody else out there knowing about it. Now, before I go too into that, let's talk a little bit about how this type of vulnerability management works in IT. So in order for really any of these strategies to work, we need an intact and comprehensive cybersecurity community, and that community needs to communicate well. So for us, at least, where I work, CISA is one of the major organizations that handle things like vulnerabilities. And that is to say, let's say I write a bug, or a vulnerability, right? So it's both, it's a bug and a vulnerability, but the vulnerability is the part that's important. So no one knows about it, including me. Now, at some point, someone could discover it. Now that person could be me, or that person could be just a random person that is trying to discover bugs in systems out there that doesn't really have malintent, but who knows what their intent is. Or it could be someone that does have malintent that discovers it. Now, kind of regardless of who it is that discovers it, once they discover it, they then have it in their payload, meaning they know this way of compromising a system that no one else knows about, including me, the developer that wrote the code that led to it. Now, at this point, this is where it's a 0 Day with the teeth. And that's because the normal way it will play out, let's just say you're working somewhere, right? Company X. Basically, some organization out there will be attacked with this at some point. In that case, it needs to be communicated quickly by the organization in question. From there, it will go to organizations like CISA and the manufacturer, or in other words, the people that wrote the code, the company that wrote the software, will become involved. And they will come up with a remedy for it, or possibly several remedies for it. And from there, it's the IT departments and any other department that deals with this stuff, honestly. It's their job to get these things fixed and remediated before the hackers that are also now aware of them, because they've been publicly announced, can exploit them. And this is kind of a neat little race, because what the adversary first needs to do is find systems that are vulnerable to the vulnerability that they've discovered. So this can be hard because we try our best not to allow you to know any information that could get you there, as in the version of the software running on the server. We try to make sure that the server will not tell you that. But if you are able to discover it, and it really could be some very subtle things that lead to that discovery, like performance, anything that you can trace to a build of a particular piece of software, you can use to kind of make an educated guess as to who's vulnerable and who's not. So that puts us in a difficult position as the IT department, because we just heard that somebody else just got their clock decked by this vulnerability, and we could be next. At the same time, we have lots of systems that need to keep working, and we have lots of vulnerabilities coming in at any given time. So first we have to assess, right? We have to take all these vulnerabilities coming in, and we have to make an assessment as to which one deserves our attention first. Because the truth is, we are writing vulnerabilities faster than we're remedying them. And that's just because we love new things and new software. And the truth is that we're just not able to remedy the bugs as quickly, and it's not as marketable, honestly. I mean, don't get me wrong, security pays very well. It's a very good field to be in, but companies still have to maintain, their schedule of releasing applications, new things. It has to be growth forever in this capitalist economy. So it's going to be hard to convince a company like Google or Microsoft to turn around and say, no more new apps. We're going to focus for the next 5 years on remedying vulnerabilities. That's just not going to happen. So, I digress there. So what happens is we have all these vulnerabilities coming in, and we are assessing them. And one of the biggest things that we assess them on is how long they've been known. Because when they are known, that means that everyone out there knows that this exists and maybe even how to do it. So at that point, they're going to try. If they can identify that we're vulnerable and they can find a way to do it, they're going to do it. So it's a race at this point. Can we fix the vulnerability? Can we cover the hole faster than they can exploit it or go through it? And, that can be challenging. One of the biggest assessments is based on, how long it's been out, but also how widespread and severe it is. That's another big metric. That if something is only affecting a small portion of systems, then it's not generally considered as serious because it's just going to have less of a niche that's willing to try to poke at it. On the other hand, if it's widespread, like the log4j vulnerability in Java was, then it's going to have a lot more impact. A lot more people are going to be trying to hack these systems. And there will be more of them to hack, of course. But then, of course, there's the severity, right? The severity is what could we potentially think of them accomplishing with this vulnerability? Vulnerabilities are not all created equal. You could have one that simply, outputs the name of the person that set up the server. And then you could have one that allows you to change data within an operating system at your whim. The severity can be very different. It's important to note that just because one vulnerability just outputs the name of the person that configured the server, that doesn't mean we're not going to fix it, just because we can't really think of that many ways that could be problematic. Because what we've learned over time is that adversaries will chain vulnerabilities together. So we may not be able to imagine how someone could do harm with one vulnerability, the one that outputs the name of the person that configured the server, but we can see if you combine that with some other vulnerabilities, like maybe the ability to hack that person's email account, those put together could be problematic. So basically, this is generally how it happens, but there is a worst case scenario. The worst case scenario is what if the adversary that gets, the vulnerability, what if they don't attack someone else or go to the company directly to remediate it? What if they decide to attack you first? Now, in truth, obviously, they can try to attack multiple people at a time, and they generally do. But if you are one of the unlucky few, this is a very disadvantageous place to be at. And this is why we cling to the word 0 day. Because what 0 day really means is that you had 0 days to deal with this. You had 0 days to prepare. So what you could be talking about here is that an adversary has a way of infiltrating either your network, your application, or both, or a lot of other, basically anywhere you don't want them to be, they could get. And anything you don't want them to know, they could know. So how are you going to defend against this? Well, you have no way of knowing what they've discovered. And there's really no way, it's not really practical in most situations anyway, to try to organically discover it the way that this adversary did. The likelihood you're going to find it that way isn't great, but maybe worth doing if you don't really have any other options. But in general, you don't have any way of preventing this vulnerability, this exploit, as we call it, to be carried out on you. So there's a limit to what you can really do if you are the first strike target. And one of those is to segment your network. or segment, everything you can, really, even the applications within that network. Try to make safeguards, try to make compartments. That way, you have the ability to lock down those compartments and trap the hackers inside your system and plug the way they got in the first place. So that buys you some time, although it's definitely not perfect, because if you can't figure that out sort of quickly, then they're just going to keep coming in. So you may even have to close that door temporarily and cut off that service to your own users. But that is all worth it in the scenario we're talking about, because this is a nightmare scenario, and it's one that we play out mostly in like tabletop exercises and things like this. But it also does and has happened. It happens to many organizations. Big companies suffer from it. Government organizations suffer from it. Even smaller government organizations somewhat lately have been being hit with this. It's not always about how important you are. It's really more about how important you are compared to how prepared you are. Because if you're very prepared, like the government, the United States government would be, like Google would be, then you're gonna be a lot harder of a target. So just because you're not a big fish doesn't mean that you aren't a target. Now that being said, if you're just some average Joe on your personal computer, this is something that you need to worry about a lot less in most cases. One, because you don't really have any good way of keeping up with this stuff. It takes teams of people to handle these things, teams of expertise, and generally the change has to be made by the people with the authority to do so. So if you're just on your regular computer, let Microsoft handle the vulnerabilities, or Apple, and just make sure you're applying patches. But there's really not much you can do yourself, aside from, I guess, if you hear about a really game-breaking bug, then you could simply disconnect your machine from the internet and prevent yourself from being hacked. So there's really nothing you can do as an individual, but as IT departments or software companies go, they are constantly looking at these things. If you're looking for a career to get into, cybersecurity can be a very, very good one. And this is why, because this is a constant struggle and it shows no signs of getting any easier. If anything, it's gonna get worse. And the reason it's gonna get worse is because we're writing more vulnerabilities than we're remedying currently. And that doesn't even begin to talk about insider threat, right? What if an adversary like a nation state were to be able to infiltrate one of our software companies like Microsoft? Microsoft, a software company that makes software that runs on pretty much every government system. If it's not Linux, it's Microsoft, right? So that, like, how do we know someone didn't get an agent in there and purposely inserted a vulnerability? That would be considered a zero day. But in this case, it wouldn't have even had to have been discovered. Somebody's aware of it because they created it. And these are things that we worry about a lot. And assessing potential impact can be very difficult. But the day metric holds strong, because regardless of what the vulnerability is, the fact that it's out there and everyone knows about it means that more people are going to try to hit you with it. So, to summarize, 0 days sounds cool. That's the first thing. Another thing is that the amount of days a vulnerability has existed is very pertinent to remediating it. The next third reason is that it still sounds cool. And then the next reason is basically that, if you're hit with a 0 day, you had 0 days to prepare, so you pretty much didn't have a chance, at least to prevent it. So, guys, I hope this helps. I haven't been doing many videos lately, and I want to try to do a little bit more. The truth is, I am sort of running out of ideas for things to talk about, so I tend to only come out and do these videos, when I have something on my mind, and this one was there today. So, have a good night.